Hello everyone, my name is Daniel Alexak, the current IEEE president here at CBU, and in this 4-part video series I'm going to be demonstrating to instructors how to facilitate and teach the mini gaming PCB workshop program developed here at CBU by IEEE. Today I will be demonstrating how to teach the first of 4 workshops, the PCB workshop. So coming into our master file where everything is prepped for the instructor, you will see that you already have the slides, the libraries, the boards, and schematic needed. And in this video, I will show you how to utilize and teach these resources. So first things first, coming into our master file here, you'll see that everything is already given to you, and what you're going to want to do for this video is go into the presentations and go into the PCB workshop. That's going to be the first workshop that we have, and essentially I'm going to just step you through every single one of these slides and show you what you should be demonstrating to the class as you go along. And this is built to help you if you have no knowledge on Eagle or anything related to these videos. This should walk you through it step by step. So before we start, this is where you want to make sure that every single student has Eagle downloaded. I made sure Snap EDA is no longer a requirement, but I'll still show students how to do it. And instead, you want to make sure that every single student has everything that is in the Eagle library right here. So by any means, you're going to want to distribute these to the students and ensure that they can actually have these before we start. To get Eagle onto a PC, you need to make sure every single student has a Autodesk account, which is free for students, and make sure they have it downloaded. So going to the first official slide explaining what a PCB is, this is where you're going to be elaborating on why we are making these workshops and why PCB is so important for electrical engineers and just for engineering designs in general. You can just read from these slides, but it's quite important to actually have a general understanding of what a PCB is. I have a nice visual here to break it down piece by piece, but essentially what this next slide is combining with that last slide is that PCBs are used after you have breadboarded out a schematic and you know exactly how every single part of the board is supposed to work, and you have a working prototype. You want to turn it into a PCB just to remove all the clutter of different wires and make sure that nothing can fall off, break, blow out, anything of the sorts with a usual breadboard schematic. So here's where we're going to be breaking down at a very high level to these students what they're going to be making and what this workshop is essentially about. And that is to make a fun, easy project to get them to understand the different parts, main components of electrical engineering. And we're going to be doing that by making this mini PCB, which is essentially just a small video game player that we have about 5 different games for and is relatively cheap just to get the students some hands-on experiences. So before we start, this is a big thing. I don't know why this is still a problem with Eagle, but after the students have downloaded Eagle from the Autodesk website, there's always going to be a problem with some students where if they try to launch it on their computer, it will show the Eagle icon and then it will just close immediately. This is due to a common error that can be found online, where one of the files just needs to be changed. You can see the direct file path there, and you want to walk through every single student's computers and make sure that they have this changed if they're unable to open it, and make sure once again that they have this file downloaded of all the different libraries before we get started. So like I said, I will be walking you through step by step how to actually utilize Eagle while also being able to use the presentation hand in hand. So for the first part of this class, you're going to be wanting to teach the students how to open a project and actually make their first file. Get familiar with this UI because it is quite cluttered and it's very overwhelming at first, but I promise you it's very easy. You're going to want to click down on projects. You're going to want to open this projects folder. I already had it opened. Right click it, new project, and then you're going to want to name this mini gaming PCB. For our sake, I'm just going to name it test and hit enter. What a project is essentially now everything that is underneath this is going to be bunched together and exported all together when we get to that step. And so we're going to be putting a schematic and a board in here. So starting out, you're going to right click and click new and then make a new schematic. This is the very first step to everything that we're going to be doing today. So I'll split screen this and keep walking you through it. So getting familiar with the UI. Like I said, this is very overwhelming at first because you don't understand what's going on here. You don't understand what every button does, but I promise you this is very simplified and is meant for high school students. So walking it through, you have the schematic in the board, like I mentioned. The schematic, what this part is, what we're seeing right here, is a part of the program where you're actually going to be declaring what parts and what connections need to be made on the board. So you're going to be placing all your different components. In this case, our last slide showed that these are the different parts that we're going to be placing on the schematic, and this is where we're going to be declaring what wires need to be attached to where. This is not the actual physical board, so the cleanliness of this does not matter as much, but it's still advised to keep a neat workspace per se on this side. So the main buttons that you really want to convey to the students that you need in this section is right here: net, add part, name, and value. Those are the four main components. There's so much going on here, but really all you need to be looking at on this side of the board are those four buttons. And so what each of these buttons do is add part, obviously, is going to be where you start placing all your different components onto our schematic. Net is how you're going to be wiring them, although I will show you a different way to do it that's more efficient. Name is how you're going to be changing the name, obviously, of each component. And value is if we have to change the value of, say, a resistor, which in this case we do. So these are the four buttons that we're going to want to get used to. Now, before we can actually do that, one of the things you want to explain to students is that if I open the add part here, there are loads and loads of different default libraries that come pre-installed with Eagle. But if you have something that is not pre-installed here, the way to get it is to go to a website such as Snap EDA. I will not show this in the video right now, but you can just explain to the students that websites like Snap EDA are where you would go to search up the technical name for each part and download the footprint. As you can see here, we have different steps for how to do it. But essentially, this is where you're going to be downloading the library, which I've already done for every student because I found that in my time of teaching these, it takes way too long to get every student to do that. So it's just better to provide it and then explain that that's how they would go about getting each one of these components. As far as the important libraries in our default ones that we have here, pinhead, switch, diode, supply 1, and RCL, and then RUS in that library are the most important and are actually some that we'll be using. Pinhead is a general library that is used for if you do not have a specific schematic or a specific part that you can find. This is just a general library that shows a lot of different default spacing for different parts. So let's say you're using an Arduino Nano that has a 2x18 row of pins. This can be used to help place that there, and then you can wire up every single one of the pins. So pinhead is a default library for different pin sizes. Switch is where you're going to be going for something like the switch that we have in this library for an on and off switch. Diodes are beyond this class, but it's still an important one to know. The students don't need to understand what diodes are in this lecture though, so you might want to skip that one. Supply 1 is very important because that's where you're going to be getting things such as ground and 5 volts and everything of the sorts. And RCL is very, very important. If I see diode here, sorry about that. RCL is very, very important, easily the most important of all the ones here, because that's where you're going to find resistors, capacitors, and inductors. So if you come down to RUS, you're going to see here loads and loads and loads of different resistors. And one important thing to teach the students about the UI here is that there's this popularity tab, so you can see which ones are the most common. And when you click on each one of these, this is the physical component on the right of what it will look like when it's on your board. So that's how you know if it's going to be matching the same thing that you have. For example, in this class or in this presentation, we're going to be using these ones because the boards that we're using have what is called a surface mount resistor, and this is the footprint for them. If you're not to use a surface mount resistor, you can see in popularity, they're these normal ones that you would typically see for the resistor that we use on a breadboard. So those are the important default libraries. Now, to get to students, the first thing that we're going to need to do is that pretty much everything in this is going to be a custom footprint. So the way to do that is to open Library Manager, click Available, Browse, and then you're going to locate where you have your different schematics. So for me, or sorry, your different libraries. So for me, this is in our master file again here, Eagle Library. You're going to collect all these, open, give it a minute to upload every single one of them. And after you upload all those libraries, you will see that they're populated right here. You're going to highlight all of those and click Use. Essentially what this is doing is now, instead of just all the default libraries that we have, we are adding in our own and ensuring that we can use them in our schematic here. So now if I click add a part and I scroll to the very top, I started them with a 0 so they'll populate immediately. You'll see that we can now utilize all of the schematics that we needed here, all of our custom components. So I will now be teaching you how to actually build this board now that we have the general outline of what our UI looks like and how to import our libraries. So this part is mostly meant for after you show the students how to do a few connections. You want to let them try, because again, this is not just a follow along, you want them to attempt to make this themselves so they can really go home and say, I feel like I built this board myself. So if I'm displaying how to do this, this is our ATtiny. If I were to add one of these, and what this is our embedded system or our microprocessor for the component. When you double click on a component, you'll see that it can float anywhere on our schematic and you'll be able to place it, and we're going to be doing that for all the components here. So we have our buttons. This was our embedded system or our microcontroller. We have our buttons, we have a ground, we have a power supply, switch, a screen, resistors, and a speaker. So I will be placing 4 buttons in an ATtiny. I will be placing our power supply, 1 OLED screen, a speaker, and a switch. And now this is the part where you're actually going to need to go and find either battery or some of the other components or some of the other libraries, like I said, called supply 1. And there are a few default things that we're going to need. We're going to need RCL, RUS, popularity, 603. And we're going to need 1, 2, 3, 4, 5, 6 different resistors. And then you're going to want to find the supply 1 library and click on ground. And we'll just throw in 3 of these. So after you populate all the components on the board, this is declaring to Eagle, these are all the components that our board is going to be using. It now recognizes all these and it's just waiting for us to wire them up. So the way you're going to want to explain it to students how to wire it up is that's what our net button is for. Again, you were just clicking on add part. The second most important one is net. So what net does, if you click on it, you can see it'll make a little circle around every single one of these pins that we have for each component. And if you were to click on one, it's allowing you to say, hey, these two are connected. This is what we need. Now you can do that for a few of them. As you can see, I want them to follow along with the schematic that I have here. You can see that's actually required for quite a few of these, like button 2 is going to be connected to resistor 3 and so on and so forth. But one of the better ways to explain it, as you can see in the shortcuts here, is something called a breakout pin. If you were to right click on the middle of component, first of all, that's how you move around components, is by dragging the middle of this part. If you're going to right click this part in the middle, hover breakout pins, all pins, and none. And as you can see there, it makes a default set of wires that are protruding from every component or from this component. And you can do that with every component. If you go to breakout pins, none. And that will just output these default wires. Now you might be wondering why we want to do that. And the reason is because instead of having to physically wire up every single one of these pieces, and they might just make an absolute rat's nest of crossing each other, what you can do is if you have, for example, the VCC pin here, if you right click and click name, and we name this VCC, it'll say, hey, where do you want to place the label? This part isn't the important part. What you want to do is now, if we have our switch going here, you can see in our schematic, the VCC pin 1, if I do breakout pins, all pins, none, is supposed to be wired to VCC. So I'll click name, VCC, rename it, and it'll give you a warning saying, do you want to connect these two together? And you say yes. So what this is doing is essentially the same as saying if I were to click net and wire this all the way over here, it's doing the same thing. These are saying these are now connected on the same plane. And as you can see here, that's what is done for pretty much every single one of these components. If I right click this, click name, VCC, it's now saying you're going to be connecting this to the same part as all the other ones. And so that's going to be the core of how to actually build this design and show the students how to do this, is to just follow along with what I have here, use all the same naming conventions, use the net, and use the name. And again, you can also just click the button name here, and you can click on a wire, and let's see, PB1 is supposed to be connected to the speaker, so I named it speaker. I'm going to put that right there. And then if I come over to where I place my speaker, I do breakout pins, all pins, none, and I say this is now connected. Let me actually use this name button, and I call this speaker. It's going to do the same thing. And so now that wire is connected to that wire, just that it doesn't look as cluttered. So again, you're just going to want to show the students how to connect all of these together using all the libraries. The main takeaways is how to use add parts, some of the default libraries that we need, make sure everything is grounded, make sure all the connections are made, make sure they're using our given special libraries, and make sure everything is named in the same way. After this, just moving along for the sake of how long this video is, you're going to be teaching the students how to actually make the board. So to make the board after you have the schematic, because again, this is not the board itself. This is not what you're going to be ordering. This is just declaring what components the board has and where the connections need to be made. You're going to click on this button up here that says generate/switch to board. When you click on that, it's going to ask you if you want to create the schematic because it does not, or create the board because it does not exist. You're going to click yes, and you're going to be greeted with a board itself. And these are all the components that we just had. And so you can see we are finally onto the stage where we are making our physical board. So I'm going to split screen this just so I can show you what parts we're doing on the presentation with this. And this is once again getting familiar with the UI. It's a lot of clutter. It just looks very confusing at first, but I promise you it's not, because again, we only need to focus on 3 or so buttons on this. So on what is the board, this is where you are actually making the physical board and declaring to the manufacturer where every single drill, where every single component, and where everything needs to actually be placed. So if I were to just click on manufacturer's view on this button here, this is the physical dimension of my board, and these 2 components that I placed on here are showing where the holes are going to be. And so this is where the wiring and everything of the sorts actually is very crucial for this board, because this is where our connections saying where things need to be connected is very important. And so again, I'm just going to give you a general overview of how this is to be done, but this is the board that they are to be mimicking. You can follow each trace and it should be the same as connected. But what you're going to want to do is you're going to want to move everything onto the actual board. Sorry about that, can't put that over there. You're going to want to move everything onto the board, so now it's physically, it will show up in the manufacturing view. It is here. And a few things to go over in this UI. You're going to want to only focus on route air wire, layers, and rat's nest. Those are really the only crucial ones that we need to explain. So if you're looking at our board now compared to what the physical thing looked like, you have a screen on the front, a switch and the battery supply on the back, your 3 buttons, your 4 resistors, your speaker, and your AT-Tiny, which is your microcontroller. So the way to get things onto the back is if you're holding a component, if you're holding left click on that center of it, it should be explained that first, same thing with the schematic. If you right click, it's going to be rotating that object. But if you come up here while still holding the object and you let go, this button up here is going to allow you to mirror it to the other side. And what that is now doing is that it's saying that this is on the other side of the board now. So you see it was just there and it's gone now, versus if I go to the bottom side, the component has now been placed on the bottom side. This is very crucial because, like I said, the power supply and this switch, if I hover it, I can rotate it again. If I hover it and I drag up here, let go, and click mirror, it's now blue, which indicates that it's on the bottom side. If I go to manufacturer view, you'll see the switch is now on the bottom side. That's how we move components to the other side. So what we're going to want to do is move our screen there, our switch to this side, slot in our board here, or our power supply here, so that it's not overlapping anything. These are just screw holes, so it does not matter if you actually put them over there. And you can see it's already starting to take form here. You're going to want to move the speaker down, the AT tiny here, move our buttons, and then some of our resistors. Again, these should all already have connections on them. I just did not wire those up together on the schematic side, but this is what this should look like if we put this on this side. Looks like I have too many buttons and too many resistors. I do apologize for that. So I'll just put these over here for now. And what you'll notice comparatively to the default board is that the size of this board is currently just in its default shape. So what you're going to want to explain to students is that if you drag this yellow side, this is the physical dimension of our board. By sliding this over, I am shrinking it, so it's running down the cost of our actual manufacturing cost. And it's just making it a lot cleaner because this is a mini gaming PCB. We don't want to have a lot of dead space that we're not using. And so again, the most important thing on this is actually clicking the Route Air Wire button, and that's how we're going to make our physical connections. If you see, each one of these buttons should be declared as to where they should be connected. And so if I click on a Route Air Wire, click on this, it actually highlights what needs to be connected where, and this wire coming out is an actual physical wire that's going to be printed onto the board like if you were on a breadboard. But again, you're just declaring where everything is going to be manually, and there's no changing this after it's printed. So you can see there, with that two simple connection, I have now given power to these different components, or I have wired them all together. And so what you want to explain to students is that using Route Air Wire, you're just going to connect everything that is declared that needs to be connected. And importantly, I don't know if it'll allow me, there we go. It will allow me. Wires cannot cross each other. However, if I click on the layers, you see that there's a top and bottom layer. We are using a 2-layer PCB, so it's allowing us to print on both the top and the bottom side. So if I click on bottom, this wire is now going underneath the top layer, so they do not cross anymore. And this is going to be very important for getting a clean schematic like the one that we have here. I recommend the students just follow exactly the ones that I have. You can see the blue ones are the bottom board and the red ones are the top wires. And so you're going to want to explain that to the students that this is the cleanest way to do this schematic unless they otherwise find a better way to do so. But this is essentially the main part of actually making our board, is using Route Air Wire to make all of our connections on the schematic. We can get back to the schematic and fix anything that we need to if it is broken, but if not, just make sure you're making all of your connections. Walk around and explain to the students once again how to use the layers, which button they need, and then importantly, to actually finish off this demonstration, I have a note here: grounding. They should have ground planes everywhere on this board. It should say ground, as you can see by all of these different ground pins that I have here. An easy way to ensure that they do not need to make all these connections physically, because on most boards, the ground plane is the one that is going to take up the most wires on a board. But an easy solution to that is if you click on polygon and you just trace the entire size of our board after you've already manipulated its size, it should give you a pop-up that says signal name. You're going to name this GND for ground. And Eagle's immediately going to understand now that the entire board is going to be set to ground plane. And what that means is that we no longer need to make a physical connection to all the ground pins, because they are already all grounded if they are not connected otherwise. And so you're going to want to make sure that they do this for the top and the bottom. And now that entire board is grounded. So if I were to click on Rat's Nest, you won't really see it here because I did not connect ground to anything. But it would say, for example, if this button needs to be grounded right here, which I believe it is, then it would be connected to ground by default. So you no longer need to worry about actually making the physical connections to ground. And so this is essentially all the things that you're going to want to show the students for actually making the board, is how to do wiring, how to ground plane, and how to actually change the physical dimensions of their board, and then how to put things on the backside of a board. So one final thing to explain to students, once again, this is a you try, so you want to aid them, you want to show them a few tricks, but you want to let them have creative freedom over this and try to make it themselves. On the final slide, this is advanced, so you don't need to do this part, but if you were to actually want to order this board or any board that you've made, you're going to come up here to generate cam data, save it, and then you're going to want to click OK. And what this is going to do is create a Gerber file, which you will send into manufacturers, and this will be essentially the machine code for how their machines are going to be building all of our traces and all of our physical connections. So I hope this demonstration helps you explain to students how you are actually to teach the class and how to guide along students through this amazing exploration of Eagle, and how to guide through the first part of this workshop.